Endless varieties exist in the world of colour. To completely understand these variations, we need to organise the properties of colour into a system. The most basic of these systems is the colour wheel. The first colour wheel was devised by Isaac Newton and came about as a result of his experiments with light. Newton took the colour spectrum and wrapped it into a circle. His colour wheel looks like this and has unequal divisions as it shows the proportion of each colour in the light spectrum. Since then, there have been many variations of the colour wheel idea, and the one you use will depend on your goal. This is the process colour wheel. It uses yellow, magenta and cyan as primary colours, with their mixtures in between. The Munsell colour wheel is a 20-step colour wheel with 5 primary, or as Munsell called them, principal colours. These are based not on colour mixing, but on after-image effects. This colour wheel is based on the way the computer handles colour. It sees red, blue and green as the 3 light primaries, mixing to yellow, cyan and magenta, the printer's primary colours. As in other colour wheels, the mixtures are shown in between. This is Johannes Itten's colour wheel. It is based on the mixing of pigments. It has red, yellow and blue as primary colours, with green, violet and orange as their complementaries. It is the most popularly used colour wheel and will be the basic colour wheel used in this program. The problem with colour wheels is that they only show 2 dimensions of colour. For example, this colour wheel has black at the centre and shows shades of the pure colours. This one has white at the centre and shows tints. Neither of them has any information about saturation, nor do they show shades and tints of desaturated colours. For this, we need a 3-dimensional model. Grey is at the very centre of the model. This grey is perfectly neutral. It's exactly halfway between black and white, and has no hint of colour whatsoever. When we add black to the grey, the shades gradually darken towards the bottom of the model, and when we add white, they lighten towards the top. This is the grayscale. It forms the core of the colour model. Pure colours are found on the perimeter. Red, blue and yellow are the primary colours and in theory cannot be mixed from other colours. When we mix red and yellow, orange is the result. We get green from blue and yellow, and violet is a mixture of red and blue. These are the secondary colours. Additional colours occur between the secondary colours and the primaries. These are blue-green, yellow-green, yellow-orange, red-orange, red-violet and blue-violet. All of the centre perimeter colours should be regarded as pure, as they are found in the light spectrum and contain no black, white or grey. When pure colours are mixed with neutral grey, they are said to become desaturated. Here, fully saturated red is gradually mixing towards the centre and is desaturating until there is no red left at all. Colours opposite one another on the colour wheel are called complementary colours or complementary pairs. Green is the complementary of red. In theory, neutral grey can be mixed from complementary pairs. So when we mix red and green together, neutral grey should be achieved. Other complementary pairs are blue and orange, yellow and violet, red-violet and yellow-green, red-orange and blue-green, and blue-violet and yellow-orange. When the pure colours at the perimeter are mixed with white, they become tints. Here we see red tinting through a range of pinks to white at the top. When they are mixed with black, they are referred to as shades. Red makes a rich range of red-browns. Tints and shades of the other colours form a shell around the grayscale core of the colour model. These tints and shades of pure colours should be regarded as fully saturated, as their intensity has only been affected by white or black, not by the addition of grey or a complementary colour. If we add the desaturated colours, the colour cylinder is complete. The colours that lie within the colour cylinder are easier to see clearly when we look at them in slices of complementary pairs. This is the orange-blue slice. pure blue and orange are here, and black and white are here. All of the other colours are derived from combinations of these four colours. We can see the grayscale core running up the middle, blending into the tints and shades of pure blue and orange on the edges. In this model there are 6 slices. Each is a combination of a primary and a secondary or 2 tertiary colours. This is the yellow, orange, blue, violet slice, and this yellow and violet, yellow, green and red, violet, green and red, and lastly blue, green and red, orange. With practice, you'll be able to visualize the position of any colour on the three-dimensional model. Using this model and information contained in the colour bias and colour mixing sections of this DVD, you'll be able to mix any colour with ease.